Page 371, question number 44 asks us to divide square root of 5 by square root of 8x. We also need to rationalize the denominator. Should not have a square root in our denominator on our final answer. First thing I would try to do is reduce 5 over 8. It does not reduce, so we can't do that. So we need to multiply the denominator by something so that it comes out even when I take the square root. So 8, we could multiply by 8 and get 64, and that'll come out even, and that'll work. You're just going to have more reducing to do. There's actually a smaller perfect square that has a factor of 8, 16. I can multiply 8 times 2 to get 16. Square root of x does not come out even. But if I multiply by x and get x squared, now it will. Multiplying the bottom by root 2x, the top needs to be multiplied by the same thing. So in the numerator, I get square root of 10x. On the bottom, I get 4x. Notice my square root's gone. Square root of 10, if it can be reduced, we need to. Factors of 10 would be 1 times 10, 2 times 5. None of those are perfect squares other than 1. So that is our answer. I mentioned before it would work if you multiply by 8 instead of 2. So I'm going to show you the work for that. This would be square root of 8x. This would be square root of 8x, giving us square root of 64x squared, which does come out even. That's 8x. In the numerator, I've got square root of 40x. The problem is 40 can be reduced. We want to reduce that to square root of 4 times square root of 10. And now I get 2 times square root of 10x over 8x. And then this 2 over 8 reduces to 1 over 4. So notice it's going to be easiest to get there if we find the smallest perfect square that works. But if you don't, you can still do it. There's just going to be more reducing you need to do and canceling.